In part 3 of this lecture on using GLHEPRO for ground heat exchanger design, I'm going to introduce an example, and then after that, we'll do a sort of a live demo of it. So this is example's it's a 3-story office building, and it's based on the medium office building reference model from Drew et al. In 2011, there was a report released by the U.S. Department of Energy that where they had developed quite a few reference models, baseline cases for ASHRAE 90.1. So this particular model, it's a 3-story office building. It uses 3 VAV systems. The zones have electric reheat, and they have packaged air conditioning units. The reference building was actually in Denver. I moved it to Stillwater. So in other words, I simulated it with the Stillwater weather file. I did this in Energy Plus version 9.2, so I output the hourly heating and cooling coil loads for the 3 package air conditioning units, plus the reheat coils in the zones. And I obtained the block loads by summing all the hourly heating loads together and all the hourly cooling loads together. It may not be perfectly appropriate. I didn't delve too deeply into the controls of this system, but it does have a way to reheat or to heat without using reheat. So we're just going to assume it's correct. I think for this case, it's reasonably close, right? And this is not an Energy Plus training lecture, right? And I won't even claim that the loads are exactly right. That I certainly didn't spend a lot of time carefully studying all the system parameters and so on. But what I did add, and I'll just put this here, is I added these outputs. I got the heating coil heating rate, and that gave me the heating coil rate for all the reheat coils and for the packaged AC unit. So I added them all together to get the hourly block heating load. And then same thing for the cooling coil, only there's no recool coils, there's just 3 cooling coils, so I just summed those up to get the cooling loads. And this building, as you might imagine, an office building in Stillwater, has quite high cooling loads compared to the heating loads. So the orange here are the cooling loads and the blue are the heating loads. And the annual cooling loads summed together, they're 7.4 times the annual heating load. So this is what we would call a cooling dominated building. Okay, so earlier in the ground heat exchanger modeling lecture, we estimated some properties for the ground, and we actually estimated the borehole thermal resistance from a thermal response test. And I also estimated the undisturbed ground temperature, which I see I've got one typo here, so I will fix that. Okay, I fixed the borehole thermal resistance in IP units. We actually estimated it here, and I also noticed after the fact that I had an error in my example in that lecture. So I had an extra 0 here. So when I fixed that, that changed our estimate of the borehole thermal resistance. The ground temperature, I took the average of a lot of measurements. I'm giving is 17.53, right? And I've kept this extra decimal place or extra digit here. And likewise for the in IP units, it would be 63.55 Fahrenheit, but that's really a little more accurate than we can measure it. So, but it's sometimes convenient if you're switching back and forth between units. You'd like to get the same results without introducing a rounding error. Okay, so what I plan to do with the example is I plan to analyze the hourly loads in the peak load analysis tool, then utilize the ground properties that we determined with the thermal response test, so those on the last slide. I'll start with a conventional borehole design, and we'll utilize the heat pump that we analyzed in the lecture on modeling of ground source heat pumps. We'll do some iterative revision of the design. And then I plan to check the sensitivity to the corrections in the heat pump model. So in the lecture on modeling of the ground source heat pump, we looked at the fitting these equations using the data that comes right from the manufacturer's main table, and then afterwards, if we correct it for the actual entering air conditions and so on, and having antifreeze, and we'll see how much difference that makes. Also look at the sensitivity to the undisturbed ground temperature and sensitivity to the design temperatures. That may take several parts. Okay, so we'll get started momentarily. We'll come back with part 4.